To answer that question, the cos of x plus y, I don't think you need to know that. Okay, so don't worry about it. Okay, so with tangent, you need to remember your exact values. So first quadrant, so that's for your exact values, and then you use the symmetry in the other quadrants. So exact value 0, bound 6, bound 4, bound 3, bound 2. For tangent, for tangent of 0 is 0, undefined. Tangent of power 4 is 1, pound 6 is 1 over root 3, and pound 3 is root 3. Okay, so you can see that pattern. It tells you that it's increasing in the first quadrant. Okay, domain, you need to remember what the domain is. So it's R, but you need to exclude the pound 2, so it's pound 2, and the period of the function tangent is pi. So the asymptote, or the values you exclude for x, will follow the same repetition, the same pattern. So it's k pi. Okay, range is R. Okay, so on your Cartesian plane, you must at least have one period. If you need to draw more than one period, once you have a full period, you just like copy paste. Okay, before and after. So we have 0, let's say we have we must have pound 2, negative pound 2. That tells you, using the domain, that you have vertical asymptote. Okay, now from 0 to pound 2, it's your first quadrant. Okay, so tangent of 0 is 0. When you get to so pound 4 is exactly in the middle. So pound 4 is here, and let's say you have 1. It needs to go through y equals 1. So that's 1 that goes through here. Okay. Something with the derivative, and that's from 9i. When you do the derivative of tangent, it's sec squared. You substitute so it's sec squared, but when you substitute x equals 0, your cos of 0 is 1. The gradient of the tangent at the intersect is actually 1. So let's say I draw my tangent, and that's coming from just 9i. That's an additional information that will help you to graph it. Okay, so on the first quadrant, the way you graph it is you follow your tangent. You need to go through that point. So because you need to go through that point, you need to kind of do it's going to have to be a straight line artificially for now, and then once you pass that point, then you can start curving up to follow your asymptote like that. Okay, so that's your first quadrant. Okay, now if you go from negative pound 2 to 0, okay, because you go backwards, it's actually your fourth quadrant. Okay, and in the fourth quadrant, tangent is the opposite of the first quadrant. So to do the opposite is you draw exactly the same, but because it's a negative, you're going to flip it into the negative side. So it's going to be, again, follow that tangent, and you go downward. Okay, The reason it curves after 1 is because of that asymptote. It needs to get as close as possible, but not, so you need to turn that way. You can't go that way. If you go that way, you're gonna tend to cross the asymptote. So you need to kind of start moving parallel to your asymptote. That's the idea. Now that's a full period, so we can duplicate that to the right and to the left if needed. So to the right, you add another whole period. So it's that's from negative 0.2 to 0.2. You go to you have pi, and then you will have 3.2. That's the full period. I'm not really scaled, so it's terrible. So that's another asymptote. At 0, you have a 0. You have your intercept. You add pi, that gives you your next intercept, and again you follow kind of the same pattern. Okay, and you could do that on the left if you wanted to. Okay, now let's say you wanted to go, it's asking you to graph the curve from 0 to let's say 2 pi. 2 pi again is going here. That is a copy of that negative side, and you can continue like that. Okay, so that's how you would graph the curve y equals tangent of x. Yes, correct, but I didn't restrict it to 0 to pi. I continued. Now if you stop at 2 pi and you start from 0, you do a full dot to stop and to start and end the function, and you will annotate the coordinates of the endpoints. Now this is a basic function you need to know for tangent. Yes, always annotate endpoints. All intercepts. For this function you don't need to worry about minimum and maximum, but you will have to do that for sine and cos. What I was about to say, so this is your basic tangent that you need to be able to sketch. The reason why usually they will be asking you to sketch or graph a tangent function, but it will have transformations. So if it has your transformation, you need to keep that in mind. Any translation to the left or to the right will shift your asymptote to the left and to the right. Okay, if you have a vertical translation upwards or downwards, it will affect the position of your midpoint, because it will not be the intercepts anymore. So let's say I add 1, that point will go up 1. That will give you a new y-intercept, but your x-intercept will be shifted to the left. What else can change? If you have a coefficient in front of x, it will affect the whole period. So remember the formula, pi over n. So if your function is tangent of nx, so y equals tangent of nx, your period is pi on n for tangent. So if n is a whole number and it's 3, 4, pi on 3, pi on 4, then your period gets smaller. So over an interval of 0 to 2 pi, you might have to draw more periods. Now, the change of period will affect your asymptotes. So draw your asymptotes first, because if your period is shorter, you have more asymptotes over the same interval 0 to pi. 0 to 2 pi.